conversation. Couple of quick things that I do want to address. Like we all started to get there. What are R1 and R2 defining in the graph? The x-intercepts. We want to recognize that. So I also want you to notice, here is our general equation. And so most of us already have x-intercepts down, but I want you to go to slide 17. Actually, yeah, go to slide 17. I'm going to show y'all what some other students said. Nope, we all said the same thing. Okay, let's add some extra information here. Does anyone have an idea how I could write these x-intercepts in general? Right, so I've got this generalized equation, a times x minus r1 times x minus r2. So how would I actually write those x-intercepts? Let's see.
You have to do two of them. So you do, the first one will be parenthesis r1, comma, 0, parenthesis. And the next one will be parenthesis r2, comma, 0, parenthesis. That's how I do it.
What do you think about that, Nathan? You don't know? So why do you think Lexi is saying that? Okay, so what do we know about every x-intercept, KJ?
Every intercept, we always know one.
Okay, but for an x-intercept, we always know what?
Oh, 0.
What is 0?
X.
Is that what we have up here? The x is 0 for x-intercept?
Oh, I mean,
Well, you be careful, the y is 0, right? So for an x-intercept, that y value is always 0. Always will be, okay? And so we're declaring, or at least Lexi is declaring, that R1 is always the x value of that x-intercept. Well, I mean, you can go back and check and verify it right now. What is my R1? What's R1 over there?
-3.
-3. And what is the x value of my x-intercept?
2.
X value?
-3.
-3. Right? When my x, or my R2 is 4, let's change that to 4. Right? Nope, I want it further to the side because you can't really see that well. There we go. So when my R2 is 9, what's the x value of the x-intercept?
9.
Is that fair? Okay. So Nathan, coming back to that, what do you think about Lexi's assertion? Whoops, that's not what I want. What do you think about Lexi's assertion that R1, comma 0 would be one of the x-intercepts, and R2, comma 0 would be the other x-intercept? Does that make sense? Yeah? Is that fair? Yeah? So from here, I want to talk about two quick things. Let's actually look at slide 18. And by the way, I mean, actually, I didn't see anyone typing this, but could you actually add that extra note to slide 17 so you can use this for your homework and for the graphic organizers and all those things?
Yes.
So it helps when you go back to that slide so you can add that information.
Okay, so basically,
Or not, Jaden, don't worry about it.
yeah, for our games, we should have done,
We're going to look at that page in just a second.
okay, so that doesn't have anything to do with it.
No, it has everything to do with that, but we're
That's
going to
what
look
I'm
at
saying.
that specific page in a
Well, I'm
second.
saying, like, does that, we should put them in that form, like our R1 needs to be with another 0 and then our
Right.
R2 is
Yes, because how many x-intercepts do we typically have?
2.
2. So make sure you make those notes there. So moving to slide 18.
I thought my name on here is like something of like an old lady.
What's your name?
So
Mary-
what I did is
Very
I
good.
hit the anonymize button up there so that no one's like, ooh, that's my name and I look silly. So I hit anonymize, so you got very unique names for sure. Okay, so
Winifred. Sound like a
first things first, I do want to point out, typically, how many x-intercepts do we need then? 2. Okay, does anyone see one of these though where we didn't need 2 x-intercepts? The last one. And so we're actually going to talk about that a little bit because technically you do still have 2, but we'll talk about what that looks like. So when I look up here LaShannon, what did you say for your x-intercepts on this first one?
I did negative 3, comma 0,
Like it's a little bit.
Positive 7, comma 0. Do we all agree with that, or does anyone want to push back on that answer?
Oh,
Yes.
Oh, no, for the first one, no, she's good. Well, actually, the negative 3, it wouldn't be negative 3, wouldn't it be positive?
Okay, so you think it'd be a positive 3?
And then the 7 would be negative.
And Kyla, you started to speak up. Were you going to disagree and say what Gracie said as well? Okay. So can one of you explain your reasoning so that we can all try to come to a common idea here?
In standard form, I just always think like it's the opposite, like if it's a negative, then it's gonna be positive. and if
Be
it's
careful, what
positive-
form are we looking at?
So standard form.
It accidentally said standard form on one of these, but remember, we talked about it. What form is this?
Factor?
Factored form.
So does it still do the negative thingy?
Yeah,
Yeah, because it's minus R1.
Okay, so it's minus R1. So R1 right now, is that R1 positive or negative? Positive. Does that make sense, LaShannon? Does this remind us of any other form we looked at?
Vertex.
The vertex form, right? Remember how it's x minus h squared? So we always had to take the opposite of whatever the h value, or the opposite of what sign was there. So in order to get x plus 7, I had to subtract what kind of number? A negative. Okay? Does that make sense, LaShannon? You go with that? And you're not the only one who made that mistake. Lots of us made that mistake, but we need to be careful there about that. So what would be the concavity here?
Up.
Up, because, how did you know that?
Because it's positive too.
What? So be careful. I don't ever want you to say it. If you're saying it, it's unclear what is positive to. The A is positive, right? So we want to make that note. A is positive, so I know it's concave up. We good with that? So Nathan, what would be the x-intercepts for the second one?
Negative 8, 0, and 1, 0.
Does anyone want to push back on that, or do we all agree? DJ says yes. KJ, what about you? You agree? CD? Cool. All right. So Nathan, do you think it's concave up or down?
No,
And how do you know that?
because the value of A is negative 1/3.
Okay. And I do want to point out, just the fact that it's negative tells us it's concave down, right? The fact that it's 1/3 means it's going to be a little bit wider. Remember, it's between -1 and 1. All right, so we're good there. So LaShannon, what do you think the x-intercepts would be for the third one? So you think it's a -2? So the R1 would be negative, right? So -2, is there anything else on your right with it?
comma 0,
There we go.
I think that R2 would still be positive.
Okay.
It's
So-
positive 10, comma 0.
Do we all agree, or does anyone want to push back on that?
Negative 10.
So you think -10?
Yeah, I think it
Can you give us your reasoning?
It's still,
because it's positive, so you have to add negative.
So remember, it's still x minus R2, right? So to get a plus 10, we had to subtract what kind of number? A -10. Does that make sense? It's always going to be the opposite of what you see there. You good with that idea? Okay. And concave down, and then last detail. So there was a little bit of an interesting discussion up here in group 1. We weren't quite sure what to talk about here, because I heard Gracie talking about the fact, well, I know one of the x-intercepts, and I think you were referencing, you know, it's 3, 0 right away, right? But then you're like, that 5/4, I don't know what to do with that. Does anyone have a second x-intercept that we should put down?
Don't you do, and it's like positive, comma 0, but don't you do it twice, because you got exponent up there?
So what do y'all think about that? So that's what you mean, 3, 0 and 3, 0?
Yeah.
That's what we came to as well.
Okay, so technically, is that a different x-intercept?
Yeah.
No, this is actually what we call multiplicity. We'll go into more details about this later. But we just mean that that same x-intercept shows up more than one time. And I think Gracie and DJ actually